Welcome to Short Planetary Geological Essays, narrated by Daniel Hutchinson. Martian Desert Varnish. If a Mars sample return mission occurs within the next 2 decades, Martian desert varnish samples would be most useful for returning to Earth for laboratory analysis. Scientific studies on desert varnish reveal that laminated coatings on rocks from desert environments are a good recorder of past and present environments. Martian desert varnish would contain a chronology extending back to a wetter and possibly a more biologically active period in Mars's history. Our past and current attempts to find evidence of life elsewhere in the solar system are now firmly focused on the planet Mars. Rovers on Mars' surface and orbital probes have provided information that the planet's surface suggests that liquid water was once abundant. This raises the likelihood of life either arising in Mars's past and or may still exist in some form in the present. The Mars sample return mission is scheduled for launch in the next 2 decades and will involve Martian materials being returned to Earth for scientific analysis. The Mars sample return mission is planned for retrieving collected core samples of Martian soil at certain depths. Desert varnish Earth rock samples contain a chronology of past environments, suggesting that these specific types of Martian equivalent desert varnish rock samples can be readily collectible by a rover and contain a wealth of information. In the Arizona desert on Earth, large tracts of desert land are colored black or brown by a 10 micromillimeter coating containing silica minerals and oxidized iron and manganese coating. It is the black, shiny nature of desert varnish that makes rocks coated in this way distinctive. Using high-resolution electron microscopy, it has been revealed that silica is the most important mineral present in desert varnish. When moisture is provided within the depressions on rock surfaces, small amounts of silicic acid may form. Evaporation of this moisture eventually causes concentrations of silicic acid to become greater than around 100 to 200 parts per million. Condensation on the surface of rock then produces a gel of silicic acid. During gel formation, wind-blown surface detrital material along with organic compounds are incorporated into the gel. When the gel dries, the dehydrated components are entombed in a lustrous rock coating. The accumulation of environmental products within desert varnish coatings preserves a biological, climatological, and environmental record. These highly analogous processes, also occurring on Mars, have the potential of entombing possible evidence of past life. The environmental record contained in desert varnish extends through time because it occurs in very fine layers that grow over each other. The growth pattern is very similar to that seen in stromatolites. Stromatolites are particle-binding cyanobacteria that produce layers from their growth that ultimately harden to form rock, and each layer records the environment in which it is formed. The deepest, oldest layers within the desert varnish formed in different conditions to the shallowest, youngest layer. These layers represent a record of environmental change through time, giving us a window of the desert varnish's environmental surroundings back through time. If silica exists in desert varnish like coatings on Mars as on Earth, it may contain ancient fossilized microbes and or chemical signatures of previous life. On Mars, the earliest formed layers in any stromatolite-like sequence will record a wetter, more biologically possible Martian environment. Moreover, Martian desert varnish is a better preserver of organic matter than its Earth counterpart. The reason for this is because the Martian environment is much colder and drier than that on Earth. Martian desert varnish records would extend further back in time. On Earth, desert varnish is a relatively recent rock coating generated in a time span of less than 100,000 years. Older examples are removed by physical and chemical weathering. Evidence on Mars of a record of ancient events upon ancient surfaces suggests that physical and chemical weathering is less aggressive than on Earth. This makes for Martian desert varnish a sample worth collecting and returning to Earth in future space missions. I hope you've enjoyed watching this program about Martian desert varnish.